I'm going to talk about persisted queries in GraphQL today, what they are, what they're good at, why we might want them, how they work, that sort of thing. But I also want to talk about a grander narrative, and that is the tension that typically exists between a very flexible, bespoke API and a rigid, more static API, where both of these two different ends of the spectrum offer lots of benefits and different costs to different parties. But I'm particularly interested in exploring that middle ground and seeing if there isn't some way to kind of bridge that gap and maybe pluck a little bit of the best of both worlds. So a quick bit about me. I'm Sean, coming out of San Francisco. I work at a company called OneGraph. Before that, I ran engineering for a payments company, and developer tooling has kind of been my bread and butter for a long time. So I've worked on automated testing systems and compilers and type systems and all sorts of stuff. So uh, good developer experience, good user experience is very near and dear to my heart. So let's go ahead and dive right in with the good points about GraphQL. I think everyone who's watching this, and including me, is a big fan of GraphQL, and it has a lot of benefits. There's no more overfetching, underfetching, which is great for our users, right? They're getting exactly the data they need when they need it. And for developers, we have much more flexible queries. We don't have to worry ahead of time that some sort of preordained endpoint has exactly the data we need and no more. We could just specify what we need, and this is a really liberating experience. And I would argue that over the medium to long term, this leads to a much faster product momentum, being able to deliver a product much faster. And part of that is the technology itself, and part of that is that developers tend to be much happier when using GraphQL over a longer period of time. Because of the more liberating nature, because of the happier users, there's this really lovely kind of positive feedback cycle that means that you have more energy to work on things, to solve real problems, and to ship your product faster. That said, everything does have trade-offs, and I think it's really important to acknowledge them, even in GraphQL's, or maybe especially in GraphQL's position, because for those of your colleagues who are maybe less enthusiastic about it, if you don't acknowledge the trade-offs and the challenges that GraphQL is typically associated with, then your arguments about why it's so great are going to be much less effective. So, what are some of the problems that are typically associated with GraphQL? Like there are quite a few. So consuming GraphQL API is typically heavier than a REST alternative. The request bodies can get quite large. Uh, a lot of the infrastructure and tooling that we build doesn't really work with it, including stuff like caching and rate limiting and whatnot. There's a new problem kind of around query complexity that can be difficult to implement. So let's take those at face value. So let's compare them. So for example, GraphQL is typically considerably heavier to consume than a REST API. And here we have two requests. The top one is just a simple request to a REST API, and it's going to hit the Twitter API, and it's going to pull out a list of tweets for the currently logged in user. And you can see that I have a few things. I have the authorization header here. But other than that, like I basically have like a little named URL and some JSON. So I can tell maybe the intent of this thing. I can tell the data I'm going to get back, and I can very like succinctly summarize what I'm trying to get. And if we compare that to a well-formed GraphQL query, we have our content type headers, we have our authorization header, but we also have quite a bit more text in there, right? Like we have the exact query that we're trying to do. There are a few things in here that can be a little bit nerve-wracking. So the first 10, this is an argument that's required that you may not notice just by scanning this. So GraphQL kind of just textually is quite a bit heavier. And if we were to take two different developers and just have them glance at this, most developers, and speaking honestly, would probably say that this one looks a little bit less intimidating. Also, each request is kind of unique. With that REST, URL-based approach, I can just read the URL and see /statuses, /homeline Twitter, and I get a sense of what the semantic intention is just by reading the title. Whereas every GraphQL query is kind of unique, and that makes inferring what the intention behind that query is a bit more challenging. Everyone is bespoke and a little bit of work. But also another thing is just names. Names are really important in life, but also especially in programming. Um, And REST kind of forces you to give names to lots of things. And not everyone gives every GraphQL operation a name. And that can sometimes mean that there's an important bit of semantic flag that is just missing. And I typically think of this as kind of GraphQL is more like clay, and REST is more kind of like a megalith. Um, and REST is a megalith in that it's visually very simple, right? Like rocks, just big flat rocks, are kind of very simple to visually parse. Conceptually very simple, right? You have a HTTP verb and a URL that you're hitting. The thing is, though it's visually and conceptually quite simple, it rarely fits together in the way that you're hoping it does, right? So some endpoints are too small, some are too large, and you as a consumer really have no control over that. And so you end up with something like this structure, where yes, it is visually very simple. You don't need much technology to kind of get started with something like this, just a lot of effort. But ultimately, the structure that you're building is unlikely to fit together in a seamless way. And each of those gaps represents work that you are going to have to do as a developer to make up for it in order to provide a good user experience. So either you do the work of manually filling in those gaps, or the user experience will suffer. And on the other hand, if we take raw GraphQL, so just GraphQL as it's usually written, it's very, very flexible. You can mold it however you would like, exactly the fields you would like, and the fragments, and all sorts of great things. But flexibility implies a very, very heavy trade-off, which is that it is easy to build the wrong thing, and it's easy to break things. You can pull off a bit of clay and attach it to a different part of your clay as much as you would like. But it is very likely that it is going to fall over at some point. Any sort of structural integrity, any sort of aesthetic beauty, any sort of functionality is often up to you as a developer to ensure. So it's a lot of responsibility to take on for the gain in flexibility. And as a quick aside, it's not entirely fair because most REST APIs do tend to grow a sort of expansion field approach. So Stripe has it, Twitter has it. Where you can see here, I'm pulling out a tweet, but I'm also saying, well, I'd also like to expand the attachment media key because I don't want to hit the attachments endpoint. And for the tweet fields, I really only need to have these specific fields. So you can see that also, even REST APIs tend to try to recover some of the built-in flexibility that GraphQL has. And again, that's all about trying to fill in those gaps in between those big monoliths, excuse me, megaliths. All right, so let's move on to the second point, which is that GraphQL requests are typically bigger. And this is because you send over the full request, and sometimes not just the query that you're trying to send over, but you can send over a full operation document. And then you can, in the JSON, you can specify which of the operations you want to run. And this might have multiple mutations, some subscriptions, a query, some fragments, and it's your whole application's operation document. When really you only needed to have some subset of that. And really, every byte does count because uplinks are typically much, much slower. And very importantly, they have much higher latency than user downlinks. And this is very bad on mobile. But given the theme of this conference, it would be especially bad in space, right? The latency would be tremendous. And so we really want to think about how can we minimize every bit or every byte that we're sending across the wire, if at all possible. And REST, looking at that request that we saw earlier, it was smaller. And how is it able to achieve this space savings? And really, it's by ahead of time coordination, where what's in an ideal world anyway, what's happening is that the API consumer and provider have sat down, they've discussed use cases and the needs and the apps that are going to be built, the services that are going to be built around this API. And they've kind of agreed on a certain set of endpoints that should basically make both sides happy. The client will be happy to consume and build on top of it. The server will be happy to build and provide support for. And you can kind of think of these endpoints as effectively just kind of queries that have been baked in. And the client can go and retrieve them later. And the other cool thing is that each of these queries now has a name, right? It's in the URL. The URL and the verb form a name in the REST culture. And that's really important because as GraphQL stands right now, it typically breaks a lot of the caching techniques. You really need to have a good name, a good identifier to cache something. And if you have this kind of rigid static approach, it makes it much easier to say this is a thing that we're going to cache. Versus with Clay, you can mold whatever you want, and that makes it very challenging to cache. If you think about the process, you'd have to do something like make sure the query operation is exactly the same as the one that you've cached. Make sure that the variable inputs that are going into this query are exactly the same. Make sure that the auth is exactly the same, whether it's public or private. And this kind of goes into the query complexity as well. There effectively, you have to become deeply familiar with both the domain and the technology in order to implement things like caching and complexity analysis. And REST is really nice here because REST is pre-arranged, where the server people get to kind of hold on to say, well, we know all of the endpoints. We know some are going to be smaller, we know some are going to be bigger, but we can kind of keep an eye out for which of these is going to cause troubles. And we can go ahead and commit, we can provide some sort of SLA and say, hey, we're willing to support these in production at some scale. Um, and that's not quite the same in GraphQL. Again, because we're very flexible, we can do lots of things. And if we are trying to prevent some sort of pathological GraphQL query, whether intentioned or a malfeasant request, we kind of have to consider depth limiting. So if you imagine, you have a user and you select for friends and then friends of friends, you want to make sure that they're not going 10,000 levels deep because there's no service in the world that is going to be able to handle the explosion and complexity of that. You also want to limit the amount, right? So if there are a million items, you probably want to make sure that I'm paginating at maybe 100 at a time versus trying to pull down a million all at once. And then there are other kind of more crude mechanisms like just time or memory or CPU or some sort of resource limiting where you say, hey, we'll run your query for up to 30 seconds, but if it hasn't returned by then, we'll just kill the whole thing. So let's go ahead and take a moment for reflection and say that, GraphQL has some really great points. It is flexible, it makes for happier users and happier developers after some time after getting used to GraphQL. But there are also challenges. Even consuming just a little bit of GraphQL typically requires understanding a whole lot of the GraphQL model, right? You have queries, you have variables, you have operation names, it's going over this post, you have a custom syntax. So there is kind of a lot, it's a bit of a step function in terms of the learning curve, where to even just to kind of start dabbling your toes in a production manner does require a lot of understanding. Also, it's easy to exceed the usage limits, as we've seen, and it's difficult to cache because of the flexibility. And then server-side auth can also be a bit tedious to implement, whereas in REST, you have a single endpoint that you can kind of lock down. In GraphQL, you kind of have to specify it at each field. What are the properties that go, the auth properties for each field? And so if we kind of look at it, we have this spectrum of the flexible dynamic GraphQL API on one side and the more rigid and pre-coordinated REST on the other side. But as we saw that REST tends to kind of over time grow this little additional appendage of expansion fields, trying to move a bit left on that graph. And maybe there is an equivalent if we were to take GraphQL and move a bit right on the graph towards that more rigid and pre-coordinated one. And that's effectively persisted queries. So GraphQL can do a lot of the benefits that we've mentioned inside of REST. And here's how it works. You're just going to use GraphQL normally during your development time. As a developer, you get to add queries and add fields and change whatever you want. It's great. But then at bundle or build time, whenever we're pushing production, we're going to have some tool that's going to walk through our entire code base, and it's going to extract all of our GraphQL queries. And then it's going to send them to the server and say, hey, I'm going to need these later. And during that storage process, the server's going to analyze them. We're going to do some depth analysis, complexity, cost, resource usage, auth, all that sort of thing. And it's possible that one of those queries will be too large. And we're going to say that, you know what, you cannot store this. You need to actually break this up because this will take too much resources of some type. And then the user will be forced to go, or the developer will be forced to go back and work around that. And this still happens at build time, so it never affects the user. But if it does pass, if the server is happy to support this, then it'll go ahead and store this, typically in a database somewhere, and it'll give it an ID and return that ID to the client. And then finally, the client is going to replace its GraphQL query locally inside of the JavaScript or the app bundle with just that ID. And the cool thing is this actually mirrors what is happening inside of the REST world. The devs and the server team are actually coordinating in this process. They're coordinating ahead of time about which queries are needed in production. And the ops and server team can kind of assign limits and say, well, we're willing to support up to this amount. That makes sense for us and for our resources. And as long as you're able to do that, then we'll provide that. And so as an example, if we take our previous query, getting a Twitter timeline, we can see it's quite large, but once we persist it, we get back just this ID. And the way we actually use this in production, going back to our original comparison, we have our REST API up here that we're hitting. We have our original raw GraphQL, very clay-like down here. And we have our persisted query, where we're calling that same endpoint down here, but we're providing a doc ID. And this is the document that was stored previously. And I would basically say that persisted GraphQL is kind of REST++. It's where the client gets to build the API, and the server just approves the API. And the cool thing is, once you have persisted that query, if we go back, no one needs to know that this is GraphQL, right? No sophisticated client or anything needs to be involved. Literally just making a curl request with a bit of JSON. And so you retain all of the flexibility for your GraphQL savvy clients, the ones who really want that. But the ones who are not yet bought into the GraphQL ecosystem or don't want to use sophisticated clients, they can just make a curl request. It's great. You get all of the build time verification that will reject pathological cases, so operations is very happy. And importantly, we now get back a single ID, which means that caching and rate limiting and auth are now infinitely easier. So I'll show a quick example of what this looks like. So over here, I have a couple of operations. I have one that is going to get the download count from NPM for a given package name. And I have one that is going to pull out some RSS feeds. So I'm going to go ahead and copy this. If I were to run this right here, this is just raw GraphQL. It would just run like normal. But what I want to do is actually come in here, and I'm going to persist this query. So I'm going to paste this in, and I'm going to go ahead and say that the user is allowed to provide a name variable, right? That's one of the variables that is inside of this query, and I want to go ahead and say the user can provide it. Importantly, whenever I persist this, I'm going to go ahead and say this can be stored, cached for up to 60 seconds. And now whenever I create this persisted query, I can just copy this. And if I go into my terminal, let's go ahead and check out the downloads for GraphQL. And so you can see, and I'll just prettify that. So you can see GraphQL has had quite a few downloads. You can see it's quite fast after the second time. And if I do React, and then again, after the second time, very fast. So you can see that I'm able to use this in a very, very simple way to just pull out the downloads from NPM. I don't have to know anything about GraphQL or any of that kind of stuff. This is just an endpoint I hit. I'll show another example where we have a RSS reader. So we're making a query into RSS, given a URL, and we're going to pull out some items and their content. And RSS doesn't change very fast, so I'll go ahead and say that 60 seconds is just fine. User can provide a URL. We'll persist this one. And now whenever I go into the URL, I can go ahead and say, let's go ahead and actually pull out one of my favorite podcasts, Jamstack Radio. So we'll provide that in there, and we'll pop that into Prettify. And here we go. We now have a podcast player inside of my terminal with little to no effort, right? I was able to take that and say, hey, I don't care about all the flexibility. I specify that ahead of time. Now I can just call it, and I get this great JavaScript-based feed. And again, caching and rate limiting is all much easier because we can just cache on that one ID. We can rate limit on that one ID and say, hey, this is an inexpensive query that we've cached, so hit as much as you like. Or this is an expensive query. You can hit this document ID up to this many times per second. And in fact, by kind of embracing the trade-offs between these two different tensions on the API spectrum, we actually end up with potentially superpowers. We can do things that neither could do on their own. We can actually attach metadata whenever we persist queries. We can do things like, who persisted it and when was it persisted and what was the client ID and the dev time, and we can get all sorts of interesting analytics. But the one I want to show today is actually auth. At persist time, we can also say, hey, here's a bit of auth that I want to provide for you. And I want you to associate this with this query. So whoever is calling this persisted document is going to go ahead, they can use my auth. And this is potentially quite dangerous because your auth may have access to very sensitive things, and an API may have access. Imagine GitHub or QuickBooks or Salesforce, where if you are embedding your auth or you're exposing your access to this API, you're potentially leaking lots of dangerous data. But sometimes you really do want to be able to set up a endpoint that can access just a subset of that API in a safe way. And persisted queries are great for this. And I'll show you an example of that using the Spotify API. So over here, I have a mutation on Spotify, and given a track ID, it is going to play that song. And I'm going to go ahead and copy this, but I'm going to persist it in a new way. So whenever I come over here to persist it, first I'm actually going to create an auth token. And we'll say GraphQL in space demo. And I'm going to auth with Spotify ahead of time. And I'm going to go ahead and get a token back that has access to my Spotify player. I'm also, for the purposes of this demo, I'm going to give it access to GitHub. And GitHub is a very sensitive API for me. It has lots of data that I wouldn't want to make public. Similarly, Twitter. So with this one token, I'm going to have access to these three separate APIs in a really powerful way. And so I want to make sure that anything I give access to it publicly is very safe. So now whenever I paste in my query, I'm going to go ahead and say that when you persist this, use that token I just created. And the user is allowed to provide the track ID and the position to start the song, because sometimes songs, they take a little while to get interesting. And now whenever I persist this query, I'm going to go ahead and come in here and I'll paste this in. And I'll also grab that track ID. And you can see that even though this is associated, this auth, with lots of really sensitive data, I can only provide two values, right? The track ID and the position. So it doesn't matter. I've really taken this incredibly flexible, incredibly powerful API and just kind of made a tiny little serverless function effectively. And so now whenever I come into my Spotify and I run this, you can see now I'm controlling my Spotify player from my terminal via a persisted query. And I can tweet this out and I can say anyone who wants can actually run this exact same query here. And if you provide a different track ID, that will actually play on my Spotify player. So if I were at a party or something like that, maybe I had this up on the wall, then anyone could just, submit a track ID and the time when the song got good and it would just work. And to drive this point home, I'll show one example where we actually use this. You can build full user-facing apps that are incredibly sophisticated using this technique. So we have a blog application that we use. We use it. We have lots of users who use it. And it's been on the front of Hacker News lots of time on popular subreddits. And because of the document ID, because of the persisted query nature, that means caching kicks in a really nice way. It means doesn't even break a sweat at all. So I'll show you how this works. So over here, I have, let's get them side by side. So over here, we have our changelog, and this is just a way for us to blog quickly about small things that have happened on one graph. And over here, it's actually driven by GitHub issues. And anyone can come and open an issue. That's absolutely fine. So I'll come in here and I'll say, hello, GraphQL in space. And everything works, so, So everything works exactly as you might expect. I'll come in here and I'll go ahead and create this issue. But nothing is actually going to change over here. If I refresh, nothing actually is live, even though this is making live queries to the GraphQL API or the GitHub API. The reason for that is anyone can create an issue, but only project admins can add labels. So if I come in here and I add a publish label, now I can come over here, and if I refresh, you can see this works just fine. And actually comments work too. And it's very, very fast. And the cool thing is, no one has to know that this is powered by GitHub. This is just basically taking our application flow and making it really nice for the user, but then powering it behind the scenes by something that we feel comfortable with. And now whenever I come in here and take off a publish label, because this is live, you can see it goes away immediately. So it's incredibly powerful. You can build very sophisticated applications. One other example of this in production is a doc editing site. So imagine that you have some API docs and you want to allow your users to come through and actually edit it, add nice updates and whatnot. In this case, we actually built a thing where users can come and edit the docs, see the changes live, and then create a PR directly from the browser. Now, the stock site is actually a private repository that they don't have access to. But that doesn't matter because we've persisted a query with just enough permissions to be able to open a PR with changes for the docs part of the site. And again, you can see I come in here and I can actually see all the other PRs as an admin that are pending. And if I like it, I can go ahead and see the original. And the very cool thing is you can see that the whole comment system, even the chat system, is powered off of GitHub chat or GitHub comments. And it works really fast for that user. They don't know that they're using, GitHub behind the scenes. We're able to use persisted queries to really mold that incredibly powerful API in the backend, and it's something that is exactly useful for just us. And one last example to show off is the Gulp site. So Gulp is an amazing JavaScript bundler, can do all sorts of things. And they have a lot of support on Open Collective and on GitHub. And so they show all their supporters down here at the bottom of the site. And you can see that they're actually making that query to get those supporters live every time you load that page with just a GraphQL persisted query. So if we look at the request doc, you can see it's just a doc ID as we saw earlier. And if we look at the preview of the results, you can see they have data coming in from Open Collective. And part of the reason they do this is because Open Collective only has very powerful API keys, and they don't want to expose their API key to the front end where anyone could use it and potentially make financial mess. And similarly with GitHub, they're getting their GitHub organization sponsors here. And so they're able to kind of mold, again, that very powerful API, two APIs in this case, and put it down into exactly one query, one doc ID that's then cached for up to 60 seconds. So they never have to worry about rate limits, never have to worry about auth issues. And it all just kind of works really well together. And this technique is used in production at tremendous scale. So the TweetDeck team uses exclusively persisted queries for all of the TweetDeck application. And there was a great talk by Tom Ashworth at a previous GraphQL conference. Strongly recommend checking it out. Also, I would strongly recommend checking out Relay. It is an amazing GraphQL client in lots and lots of different ways. I was skeptical for the longest time, and I considered that wasted time. But it's a client that actually takes persisted queries very seriously, and it's kind of has first-class support for it. So that blog I just showed you is actually written in Relay. And the thing is, as a developer, you don't even know that you are using persisted queries. You set up a function once to persist them, and then you just use GraphQL. And literally at build time, it will go through, extract everything, just like we talked about earlier, store it on the server, and it's amazing. Okay, and that's it. Happy to talk about other things. Some other cool things I didn't talk about, for example, are once you have persisted a query with lots of different operations, you now effectively have a library of functions you can call. So imagine you had like Spotify play mutation, pause, next, search, query, and you can persist that all at once. And now you have one endpoint that has all of the auth, all of the functions you need to call. And also you can generate, for example, an NPM package for that will have all the TypeScript bindings or Swift type bindings. So your consumers don't even know that it's GraphQL. They just see a list of functions that they can call and named arguments that they have to provide with their types. So the autocomplete experience is just fantastic with persisted queries. Yeah, lots of other things I'd be happy to talk about, but I think that's it for today. Cheers.